how to solve really simple trig equations. So we can solve things like cos x equals 1/2. Yep, we able to do that sort of thing. We do cos inverse of 1/2, and that would give us the value of x. Just like normal algebra, there's other things we can do. So that's a very simple equation, but we could end up with, looking at the complicated end of things, we could end up with things like 3 cos 2x plus pi over 4 minus 1 equals, no, it's not a 2, that's going to give us a bad. Let's go for the half again. Yep, we could end up with something like that. That would be the ultimate type of question we've got to be able to muck around with. Basically, a cost curve that we've described so far is just always starts at 1 and finishes at 1, top and bottom. It always goes, when I walked across the board this morning, I walked at a certain pace. What would have happened if I'd walked faster? It would have been much more spread out. Or if I'd walked really slowly while I was going up and down, you'd have to go up and down a whole lot. Yep. So cost curves can have more than just the basic picture. And these numbers in here change all these features around. Okay. So tomorrow, we're going to have a look at the actual graphs and what these things do to the graphs. But for this afternoon, I just want to be able to solve this sort of thing algebraically. Okay, so it's going to do, it's effectively rearranging an equation, and we're going to be able to solve this sort of expression. Okay, so I'm actually going to start off with a real ugly one, and if we can do that, we can do anything. So we're going to work our way through a question like this, and just see how far we go before we get stuck. And when we get stuck, we'll start thinking about what's going on. So a lot of it is just rearranging, just normal algebraic rearranging. And then when we get to the cost bit, we've got to think about what's actually going on. But it's just, again, what you did this morning with a little front end on it, effectively. So it's all maths ever is. What you've done before with a little bit extra added. It's never difficult. Okay, so let's start with this question here. So 3 cos 2x plus pi upon 4 minus 1 equals 1/2. So that'll do for an expression. Before I even start solving it, what other bit of information would you normally expect to see if I gave you a question like that? Solve that for x. Look at the ones you did. Arrange. Okay, so let's solve this for x for negative pi less than x less than pi. So we're going to solve it for that range. Okay, so degrees or radians? Radians, because it's got a pi in it. So as soon as you see a pi, you know it's radians. So when it comes to, it's time to push the buttons on your calculator, you definitely want to be in radians. Sweet. Okay, so just looking at this, if I gave you that and you didn't know anything about costs and stuff, and I said I want you to find x, and you look at that, what would be the first thing you'd want to deal with? The 1, the minus 1. So how are you going to deal with the minus 1? Plus 1 on both sides. So it's just normal rearrangement. So if I add 1 to both sides, I get 3 cos 2x plus pi over 4 equals adding 1 onto that side, 1.5. Yep, so just normal algebra. No problem with that, just deal with the minus 1 by adding it to both sides. Yep, you need to yell or throw something at me if you lose the plot at any point, but that's just we're dealing with that minus 1. What's the next thing we're going to deal with? You reckon? How are you getting inside that bracket? Take the whole bracket? So how are you going to take the bracket, Travis? What are you going to do with that? 1.5 over everything in the bracket. Okay, so this implies that there's a times in there. That you are undoing the times in there. Is there a times in there? If I asked you to put this in your calculator, if I said enter that in your calculator, would you push the times button? No. So there's no times in there. Okay, it's not cos times that, it's cos of that. Okay, so cos just going off to the side for a moment. This is a really important idea. There's some functions which are called binary functions. Okay, plus, minus, times, divide. You need to have two things before they can work. Yeah? If you only have one thing, it doesn't work. Yeah? There's some functions that aren't that. They only need one thing to work on. The classic one you've dealt with so far is that. Yep. When you want to undo the square root, you never move the actual square root symbol. Yes, if I've got square root of x equals 12, you don't suddenly end up with x equals, no, that's just crazy, isn't it? Crazy talk. Yeah, because it's not square root times x, it's square root of x. When you're undoing the square root, you do something different to the other side. Cos is the same. So cos and sine all fit on this side. Okay, they're only single functions, and you can't move them as the stuff. So you never move the cos. You do something to the other side, which is cos inverse. Yeah, does that make sense? Yep. Okay, so no, there's no times in there. You can't just take that bracket away. Okay, so sorry for that rant, a big rant in the middle of the conversation there, but really important idea. So what do we want to deal with first? The 3, because the 3 is attached by multiplication, isn't it? So we can zoom the 3 across. So we end up with cos 2x plus pi over 4 equals 1.5 divided by 3. And I can sort that out, it's just a number, it's just a half, isn't it? So cos 2x plus pi upon 4 equals a half. Yep, so that's cool. I'm happy I've dealt with all that lot. So everything that's outside the cosine, we can just strip it away using our normal algebra rules. Super. Enjoying this so far? No dramas? What's the next thing I want to deal with? The cos. Exactly. Yep, because this whole, I can't get inside here until I deal with the cos on the outside. So I have to move the cos across to the other side. So 2x plus pi upon 4 is cos inverse 0.5. Yep. Do you want to work that out? Okay, I would agree with that. So at this point, I think at this stage you want to work out the answer to this question. Work out a value for that. And Michael's about to say something, I can see it brewing. You should have your calculator in radians, yes. Yes, it'll give you the answer in radians. So it won't be, if you did it in degrees, it'll be 60 degrees or something. If you do it in radians, it'll be about 0.5 of a radian, something in that range. 1.05. Okay. Third of a, yeah, a third of pi, a sixth of pi. Yep, okay. So, but this is the point where the stuff we did this morning comes into play. So when we do this, you see, but you whack the buttons on your calculator, and you've come up with 1.05, yes? Yeah, okay? There's going to be more than one answer. Or likely to be more than one answer. It's a cosine thing. So at this stage, for me, when I'm doing that thing, I always just sketch the graph. Okay, because the drama happens when you do the cos inverse on your calculator. Because that's the one that only gives you the one answer. Every time you do cos inverse 0.5, it gives you this one answer. But we know there's more than one answer. Yeah, we know there's, okay, so 0.5 is here. So it's giving you that answer. But there's more than that answer. There's a whole bunch of answers. Yep. So at this stage, I usually stop and think, let's get a couple of answers in under the belt, and then we can play with it later on if we need to. So I would go at least, what's this answer out here as well? So what's that one going to be? Any smart ways of working that one out? This is what we did this morning. So bright ideas? 90 90 is good, except it's not 90. It's in radians this time. So this point here is not 90. It's pi over 2, isn't it? Yep. Minus the 1.05. Yep. Which will give us that little piece there. Yep. Yep. Oh, I think you want to add it on. It's here, isn't it? Yep. So this point here, what's that point there in radians? Hold that, Shane. I'll come back to it. What's this point here in radians? Pi? 3 pi over 2? Yeah, so I agree that this point here, the next point we're trying to find, is that little green bit plus 3 pi over 2. Yep. So you can work out the green bit. So the green bit is pi over 2 minus 1.05. Someone do that for me. Pi over 2 minus 1.05. Roughly about 0.5 or something. 0.52. Yep, and then that's the same as that little green bit. So if you then add that on to 3 pi over 2, you end up with pretty close to 5, I think, isn't it? 5.23, that sounds good. Yep. And while we're at it, we might as well get this one here as well. Yep. So this one here, what's this point here going to be in radians? Anyone? Got it, Travis? I can see the brain going there. You got it? Two and a half pi. Well done, Harrison. Which you can just call it 2.5 pi if you want, but I'm going to go for 5 pi over 2 because it sounds fancier. Is the only reason. So if we do that 0.52 away from there, we should be able to get the value for that point as well. .2 decimal places. Let's stop there for the moment. That's probably enough. It gives us a few. So just let me write these down. So that one's 5.23 and 7.33. Okay, so I'm going to stop for a breather for a second. I'm going to answer Shane's question, and then we're going to just check that we're happy with what. This is what we were doing this morning, pretty much. So Shane, you were saying where did that 1.05 come from? Cos inverse of negative 0.5 in radians. So calculator in radians, just do that cos inverse, and you should get that. Your calculator doesn't do that. So is your calculator in radians? It does so. Chris or Harrison, help the man out, show him how to make it do radians. The 3 pi over 2, this one, 5 pi over 2. Or as Harrison said, 2.5 pi's. Okay, so any other questions about where these numbers are coming from? What we're doing on here. So what we did this morning, the calculator gives you one answer, and then you've got to figure out where the other answers are. Okay, so when you do the inverse cosine, that's the point where the calculator should give you more than one answer but doesn't. And you've got to help it out by getting the extra answers. Yep. And if we wanted to, I mean, we could go one going this way as well. That carries on down there. What's that one going to be? Negative 1.05, isn't it? Now we're going to worry about the 2x plus pi over 4. Because these aren't the answers for x, these are the answers for 2x plus pi over 4. So a bit more algebra to do yet. But the reason that we get these points here is because it's the cosine inverse that introduces the multiple answers. Okay? So you've got to get the multiple answers at that stage, and then whatever you do, you've got to do to each of the answers. Okay? That make sense? Yep. So it's as soon as you reach for your calculator and you go shift cosine, that's the point where you've got to think, well, hang on, the calculator's only going to give me one answer here, and actually there's going to be an infinite number of answers. So at that point, you need to help the calculator out a bit and get as many answers as you need. That's the question. That is the question. How do you know how many to do? So big question that we're sort of hovering over this whole discussion. How do I know how many I need? Yes, so it definitely is going to come back to something to do with this range at the start, but we've got to get x in that range, not 2x plus 4. So there's definitely going to be some checking around with what happens. So that's a really key question. And at the moment, I'm sort of ignoring it, but we do have to, at the end, we have to do a wrap up when we check out the range. So we're sort of on the track. Okay, so is this making, you're asking questions that go into the future, which is awesome. So just looking back into the past a moment. Started with something really ugly, did a bit of basic rearranging, added 1, divided by 3, uncosigned it, freaked right out, because when you uncosine, the calculator only gives you one answer, and we want more than one answer, so we helped it out by picking off the graphs where the other answers happened, knowing full well that there's a whole bunch more that way, and there's a whole bunch more that way. Yep. So we've just got a few in the middle. There's as many as you want in both directions, which brings us back to the question we're kind of avoiding for the moment, but we'll get to it. Okay, so we now know that 2x plus 4 pi over 4 equals one of these things. Let me just write that up again. Some possible answers: negative 1.05, positive 1.05, 5.23, 7.33, and some more answers. Okay, so in general, that many answers. Okay, if I'm looking at this and I want x by itself, what's the next thing I want to deal with? Minus the pi over 4. Excellent. So 2x is going to equal that answer minus pi over 4, or this answer minus pi over 4, or this answer minus pi over 4, or this answer minus pi over 4, or one of the other answers. Yep. So whichever answer we're looking at, we've got to subtract that pi over 4. So you just go and take pi over 4 off all of your possible answers. And then depending on how your brain works, which way you want to do it, you can just work all those out as numbers now, or you can leave them as expressions and work them out as numbers at the end. It doesn't bother me either way. Just for clarity for this once, let's just work out some numbers. So grab calculators and start working out those numbers for me. What's the first one, Jaden? You look like you've got it. Negative 1.83. Beautiful. 1.84. We've got some rounding going on there. Next one, who's got the next one going? 0.26. 4.44. And Sam's going on the last one he's working on, I can see it going. 6.54. And there's a whole bunch more at the end if we need them. Yep. Brilliant. Okay. So have we got x yet? Nope. What have we got? 2x. So how am I going to get x? Divide by 2. So x, so that's still 2x. So x equals one of these answers, or this answer, divided by 2, or this answer, divided by 2, or this answer, divided by 2, or this answer, divided by 2. I just about do divided by 2s in my head. Negative 0.92, 0.13, 2.22, 3.27. There we go. Divide by 2 is like I can just about manage. Yeah. Yep, so all we do is each answer, we're just doing the algebra. So basic algebra, losing the pi over 4, losing the 2, just basic algebra with each, and we have to do with each answer. Okay, and unfortunately you can't work out the answers, do it with 1 and then jiggle them, because the problem is that it's when you do the cosine inverse that you get the multiple answers, so that's where you need to spread them all out. Okay, so there's a bunch of answers, and the question we're going to ask is, which ones do we need? But first we're going to answer Shane's question, which is, so you did this thing here, so when you've got 60 degrees here, so you've got 60 degrees, you'd have to convert that into degrees as well. So you have to change that pi over 4 into 45 degrees. And then you have to do exactly the same. So you end up with 45, a whole bunch of numbers, 60, negative 60, whatever these other things are. You have to do exactly the same process. Yeah, but you end up going in, and then to match it up to here, you have to put it back into radians at the end anyway. So you actually make yourself 2 more steps just so that you can feel comfortable in the middle with degrees. Whereas the correct response is time to think like an engineer and embrace radians, because that's where the future is. It's the most accurate. Yeah, I mean, yeah, this is rounded. We have rounded this. I mean, the most accurate way to actually deal with this is pi over 3. But when you put in your calculator, as soon as you go cos inverse of this, it's going to give you a decimal. And this one just happens to be exactly 60 degrees. If I'd given you 0.4, then even in degrees it would have been whatever it is, 48.1623. You have to chop it off anyway in degrees. So this just happens to be a nice degrees and a weird number in radians. Yeah, so we're definitely doing a bit of rounding. Yeah. Okay, so getting back on track, we now have, not that we were off track, Shane, it was a good place to go. We now have answers for x. We have all of these answers for x. Yep, and the question is, which ones do we want? Which ones are inside our range? So our range is from negative pi to pi. Okay, so I just do this by putting a line between the ones I want and the ones I don't want. So where on there does pi go? What number is pi? Pi is 3.14, so somewhere in between here, isn't it? So this one is good, or inside, and this one is outside. Yep, because we wanted to chop it off at pi. That makes sense? Yeah, I want to kill that one at pi. Is this one inside or outside? This one? Yep, because you want to go down to negative pi, don't we? So the next one here, we don't know if it's inside or outside. So we need to keep on extending in this direction till we find one that's outside, and then we know we've gone far enough. Okay? So what we're saying is, at this stage, we really need to get another number in here. Does that make sense? Yep. So I would, at this stage, let's just change the black colour so you can see what we're doing. I'll just go back to here and go, oh, where's the next one? Okay, so just extend this back a bit further. Yeah, okay, this is why you don't draw your thing next to it. You do it enough space, but you got the idea. Okay, so where's this one going to be? And maybe that one as well. What's this one going to be? It's exactly the same as that one, isn't it? On the other side. Yep, so that'll be minus 5.23. And the next one back from there will be minus 7.33. Yeah, so I've just said, I know I haven't got enough off to the left, so I've just gone back to the left and found a couple more, stuck them on my list, and I'm just going to have to work through this whole process with each of those numbers as well. Yep, so in here I'm going to get negative 5.23, negative 5.23 minus pi over 4, which equals 6.01, 6.02, and that's to divide that by 2, which is negative 3.01. Am I still inside? Have I gone far enough yet? Still inside, aren't I? So the next, that's getting kind of close to negative pi. So the next one's probably outside. So we're probably okay there. But if you want to be really sure, just grab the next one and run it through and check that it is outside. So the next one is negative 7.33. So negative 7.33 take away pi over 4, which equals negative 8.11. Oh, that's definitely going to be okay, isn't it? Divide that by 2 is negative 4.06 or something. Near enough. But, yeah, and that's clearly gone outside. So there's my bracket there as well. So this is inside, and that's outside. Okay, because my line is negative pi. So negative 3.14 is between these guys. So that's okay, and that's out. So if you extend it far enough in each direction to drop off the end, one off the end of each, then you know that you've gone far enough. And, anything else is going to still be outside your range. Okay, this is the first time you've seen this, and it's definitely the culmination of this whole block course. The stuff we're going to do tomorrow is easier. This is sort of this is it. This is the pinnacle. We sort of got to the top of the hill, and tomorrow is a bit of a downhill slope from here. So lots of algebra, lots of numbers and crunching in all directions. I'll do another example for you as well, but what I want you to do is just have a look through this and think about the bits that are what's happening at different bits, and see if we can. Okay, so I'll just very briefly just talk through it again and stop me when you're not happy. Okay, so first thing, standard algebra. Deal with the -1, deal with the 3, just straight algebra. Next thing I want to deal with is the cosine. So this is the bit where we go to inverse cosine, and we need to help out the calculator, because the calculator only gives you one answer, and you've got to extend it out and go, actually there's more than one answer, let's do a couple of answers at least at this stage. So there's our couple of answers, and then it's just back to straight algebra. Take off the pi over 4, divide by 2, bunch of answers, and then it's a matter of checking the range. And in this case, I wanted to go from negative pi to pi, and it happened to be that I'd gone far enough in this direction, but I had to go a bit further in that direction. So I had to go back, find a couple more in this direction, work through the process again, and then I was happy that I was on the right side. Yes. The fact that this has got pi's in it dictates that it's radians. Yep, this is a fine answer. If it doesn't have a degree sign on it, it's in radians. Yep. Any other questions or comments on that? I'll do another example for you so you can see it. Yep. So there's a very clear process. It's just rearranging equations with this little trick in the middle that when you uncosine, you've got to pick up a few extra answers. That's the guts of it. Yeah. It's good? It's entertaining? Yep. So if you have a look on your question 3 on your assignment, it's one of these versions. It's same sort of stuff going on. Just keep an eye on the fact, this is for when we do the next one, this 2, and there were 4 answers. And 2 times 2 happens to equal 4. So when you're starting at this stage and you're going, how many am I likely to want to do? If you double that number, you'll get an idea of how many answers you're going to have. Okay, just putting that out there, it gives you a good feel for roughly how many answers you're going to get. No, there should be a total of 4. 4 in a period. So if this was twice as big, you'd obviously get 8. But yeah, we'll talk about that tomorrow when we actually draw the graphs. But it's just a feel for how many you need. So I just used the word period, which I haven't defined at all. But we're going to talk about that tomorrow. Okay, so if I rub this out and we'll do another example. Yep. Let's do one that looks a little bit more like the question 3 on your assignment. So we'll do a sine one, and we'll do one with divide in the middle. Okay, so let's have a crack at solve two sine x minus 1.34 over 3 equals negative 0.217. Oops, hang on, got a bit of a mix up here. Let's make that something a bit more sensible. I'm going for degrees, I should have degrees in there. I'm going to step out of frame for a second. Excuse me. Nothing. Okay. Which one? So just negative 7.33. No, 7.33. Yep, minus pi. Yeah, it should be. Pi divided by 4, shut bracket, negative 8.11. That sounds weird. Yes, it is. Yeah, and then you have to divide it by 2. Okay, so jumping into this question, how many of you have already started and done the first step? Michael's confident he's got the first step right. Scott's confident he's got the first step right. Anybody else? What's the first thing you've done, guys? Well done. Change the calculator to degrees. Give that man a biscuit. Okay, so change the calculator to degrees because we've noticed that this is a degree question. So calculator is now in degrees. Awesome, well done. Very good. The next thing you're going to do is 2. What are you going to do with the 2? Divide by 2. Okay, so if you divide by 2, we get sine of this lot equals that thing divided by 2, which is negative 0.1085, I think. Someone will yell at me if I got this wrong. Yep, we're on to it, we're doing well. Okay, what's the next thing I'm going to do? Undo the sign, so that means I get a sine inverse. So x minus 45 degrees over 3 equals sine inverse negative 0.1085. Say again. Negative 6 degrees, isn't it? So that's, you've got your calculator in degrees. So negative 6 degrees. Yep, that looks about right to me. I'm happy with that. It's exciting. What do I want to do at this stage? Yeah. Is that what you mean? Yeah. It is, well done. Yeah, I missed it. 7.7 something. We have a dispute. Everybody try and do this for me and see what we come up with. How many negative 7s and how many negative 6s? 6.23. You got your calculator in degrees or radians? Degrees. Can you duplicate what you did? Ah, so did you do? No, it's 2. Yeah, but did you do sine inverse negative 0.217 divided by 2? Or did you do that? Or did you, yeah? Yeah. I don't want it. The key thing is, the thing I don't want is I don't want that. I do want that. I want that. Yeah, that's what you want. Sorry, I just freaked you out. No, Travis. What's he doing? What's he doing? Yeah, I definitely want that. You've got to do the division before the sine inverse. So you've got to do it in one step, you've got to bracket it. And when you do that, do you get, Travis, what did you get? 6.23? Seems to be a majority of 6.23s going on here, so I'm sticking with it. Just going to wait for James to see what he's... Is that still not working out? I'm just going to come and do an investigation here for a second. Let's see if I can see what we're doing. Yeah, you calculate in degrees.
Is it divided by 3 or 2?
No, it should be divided by 2. It's 2.17, not 2.71. That's what it was. No problem. Solved. I hope. Okay, so we've done the sine inverse. The calculator has told us negative 6.23 degrees. What else am I going to do at this stage? Another question, yes. Yeah, I love those questions. They're my favourites. Levi, do you have a question as well? No, I thought I saw a question there as well. Okay, so what else am I going to do at this stage? Draw the graph. Okay, so the graph I want this time is a sine curve. She goes like that. And like that. Negative 0.1 is about here somewhere. It's quite low. Yep. So this is negative 0.1085. And the answer the calculator has given us is this one here at negative 6.23 degrees. Yep. So sorry if that's a bit small at the back there, I know, mate. So that's the answer the calculator's given us, is that negative, that answer. It's given us the one closest to the start. Yep. Cool. Yeah, between 0 and 720. Right, okay, so what am I going to do now? What else am I going to do? Find some more. Okay, so let's go for this one. Looks like we could find this one. And maybe this one. And I don't know, we could find plenty of them, couldn't we? Yep. So what's this one going to be? On to what? So what's the blue cutoff point? What's that point there? 180? So that's going to be 180 plus the 6.23, isn't it? So that one's going to be 186.23. That's still looking pretty good. And this one here, what's this one going to be? So that point, well done, so that's 360. So this one's going to be 360 minus the 6.23, which is 353.77. Okay, let's leave it there for now, and then at the end we can do do we have to do any more backwards or forwards? So it's a good. Okay, so we acknowledge that there are a whole lot more here, and there are a whole lot more there. But at the moment we're just going to go with those ones there. Brilliant. Okay, awesome. I'm enjoying this. What's the next thing you want to deal with? The 3 times it by 3. Yeah, because this is all divided by 3. So this is x minus 45 degrees all divided by 3. So we're going to multiply everything by 3. So we get x minus 45 degrees equals all these answers up to each of these things times 3. So that one's going to be minus 18.69. This one's going to be some ridiculous number. 545, 3.69, is that right? 558, lost that one. And this one times it by 3 is 9, 10, 5, 9, so we got 10, 6, 1 point something. What do you got? Oh, it was 5, 9. In the close, but no biscuits. I'm not doing well here. 0.81. Yep, so just multiply each of them by 3. It's going quite nicely. And then the next thing I want to do is add 45. Yep, okay, so x equals maybe these other answers we don't know anything about. And then each of these plus 45. So that plus 45 is going to be 26.31, thank you. That one plus 45 is going to be 603. And this one plus 45 is going to be 11. And then a whole lot more. Yep, so I've done a normal process, basic algebra. At the point where you find the sine inverse in this case, pick a couple more, just so you're acknowledging that there's more than one. Kieran, what's the question? Where are we? Up, down, left, right. This one? And here. So 7. Oh, so I was right with 6-1. Look at that. Ah. Which means this is now going to be wrong as well. That's going to be, is that, no, you've done it already, haven't you, Serena? You got it right. Right, okay. Just great thing about whiteboards, you can just rub things out and change them. Because when you've got your notes, they've got big scriffles all over them where this is where the teacher was an idiot and got it wrong. You have to write your notes beside it. Okay, so we've got a bunch of answers. We've worked out the bunch of answers for sine inverse. We've multiplied them all by 3. We've added 45 to each of them. We've got this lot of answers. What's the thing we have to do now? Inside, outside. So where's the cutoff points? Yeah, so the 720 is definitely in beside here, isn't it? Yep, so this lot's inside, and this lot's outside. Super. And what about going the other way? Have we got to the end of the block yet? No, so there might be another one. We might be able to squeak another one in because we want to go down to 0. So it might be possible. Looking at the way these are spread out, 600 degrees apart, I bet the next one's going to be negative. But if you're not sure, then you just go through the process of checking it out. So you want to get the next negative one, which will be this one here. Okay, so what's that one going to be? Yeah, I agree that this is negative 180, but it's inside that, so it's going to be, yeah, so it's going to be negative 180 plus that 6.23, so it's going to be negative 173.77. That's a 7, that one, Karen. Just in case you get worried. Okay, so that's the extra answer we're putting in coming back this way. I'll do it in black, like I did last time, just so you don't lose track of it. So this one, we've got an extra answer here, negative 173.77. If we multiply that by 3, we're going to get negative 521 or something. Yep, 0.31. Brilliant. And if we add 45 onto that, we're going to get negative. Yes. So like we said, it's definitely outside, isn't it? It looked like it was going to be outside, and it sure is. So there's our line there. This one's outside. These ones are inside. So x equals 26.31 degrees and 603.69 degrees in the range, yeah. Since there's only one x, there's going to be 2 possible answers. Yeah, no, okay, so this is time out and thinking, this is what we're going to do tomorrow in detail. But yeah, the trick here is actually, that is 1/3. So that's the number. When I put that square around the 2 before, it was the thing that was multiplying the x. So here, effectively, the x is multiplied by 1/3. And if you double that, you get 2/3. So there should be 2/3 of an answer, except this is 2 periods. So normally 0 to 360 or pi to 0 to 2 pi. And when I did the circle, once around the circle, so there should be that many answers for each time you're going round. So we've got to go around twice. So if you double that, you get 4/3. So there should be 4/3 of an answer. So somewhere between either 1 or 2 answers. Just depends on where it sits in the actual thing. So 2 answers, it doesn't surprise me. It would have either been 1 or 2. Yeah. Right, okay, so process again, just looking at the process. Simple algebra, sine inverse. When you do the sine inverse, get a couple of answers. Yep, so that's where you've got to do your graph thing. Then algebra, each of those answers, check the inside-outside thing, and extend in any direction you need to extend. Yeah? you want me to write that down as a list of bullet points, if this is how you go about doing it? Yeah, I'm getting one nod's good enough. Okay, so algebra until sine or cosine is hit. Okay, so just basically divide by 2, or the last one it was +1 and divide by 3. Step 2, sine inverse or cosine inverse, and get a couple of extra points. Yep, so when you do the sine or the cosine inverse, that's when you need to get the extra points, and that's where you need to draw the wee graph. And then algebra to all the answers, and then check the range. And then go back to step 2. If more points are needed. Okay, so when you get to the end, you check your range and you go, oh, I haven't got to the end of my range. You need to go back to your point where you chose your extra points and add on another 1 or 2.